I'm going to start recording here and here.
Learn that lesson.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams, editor-in-chief of Hackaday.
I'm Tom Nardi, managing editor of Hackaday.
This is episode 167. Today we'll be talking about deadly art projects, robot lockpickers, LED horticulture, and Good Samaritan repairs. This week for news, we should start off with the second round of the Hackaday Prize, Reuse, Recycle, Revamp. The new phase started up on Sunday, and it's all about projects that use recycled parts or projects that facilitate recycling. I remember someone was making a reflectance spectrometer that would let you tell different kinds of plastic apart, for instance. And so you can tell which bin to put them in, or, does this one recycle? Does that one not? I've seen documentaries of big recycling plants, and they're all full of all of this kind of fantastic automation and systems to do recycling stuff. And I think some of that might be fun to do on a small hacker scale. And of course, there's stuff like 3D printers that use, old plastic or plastic bottles there's just a broad range of ways to go here, and I'm totally stoked to see what people come up with. Given the chip shortage, I kind of want to see someone do a part scavenger robot. Kind of like the opposite of a pick-and-place machine. Yeah. Like a pick-and-place in reverse, a pick-and-steal.
That's even specifically named, I think, on the prize website, where they talk about maybe you want to harvest parts from existing PCBs.
What have we been reduced to? But but pulling the valuable ICs off of printed circuit boards.
Yeah, what was the thing we talked about in the meeting before, where they're buying the washing machines and taking the chips out of them? Did we ever write that up?
That's right. It hasn't been written up yet. No, I think Al's going to write that up sometime. So let's see. What did you do 2 weekends ago, Tom?
I went to Vintage Computer Festival East, and as always, had an excellent time. This one was put together kind of on short notice because COVID pushed last year's out to fall. And instead of switching it to a fall event, they said, all right, we're going to, for 2022, we're going to go back to the original spring. But that only gave them 6 months, instead of a year. I had figured, okay, well, they only had 6 months. I'm sure it'll be kind of like a scaled down thing. But they, if they could put this together in 6 months, it's like, what takes a whole year? Because it was, it was fantastic, bigger and better than, the previous year. There was more talks, more workshops. Just everything really gelled together. It's always a great time. When I started going a few years ago, I got to say I didn't have a great knowledge of a lot of the vintage hardware. I just, I was the local guy, so I got sent out there to go to take some pictures. But they're just such a welcoming group. I think they saw I was a little bit naive about some of the stuff the first year. So they're like, do you want me to show you how this works? And, pretty soon I was putting in programs on the front panel of some machine older than I am. And it's just it's a really cool thing if you're even remotely interested in computing, vintage or otherwise. It's definitely worth the trip.
I've been to some of the ones in Europe, and they're varying degrees of thematic. How thematic was this one? Did it have a central organizing principle?
Yeah, they do have themes. I think the themes tend to be more for the talk side of it. This year it was, computers for the masses and women in computing, so they had a lot of female speakers, which is really cool. The exhibit stuff, though, it's almost like two shows in one, really. And I don't know if that's intentional or just kind of the way it works out, but you have kind of the exhibits where people bring their passion projects, and then you have the talks, which are very focused on whatever the theme is. And they are kind of, when you go to the event, they're physically separated in different buildings. So you could spend all day doing the talk thing, or you could just wander the exhibit. I recommend you do both because they're all awesome.
Yeah.
Plus, the talks are now, because of COVID, they started streaming them, and my understanding is they will be released on the YouTube channel once they clean them up and edit them down. So even if you spent the day looking at stuff in the exhibit, you could still check out the talks on YouTube later on.
Right on. Yeah. If anything good has come out of this last 2 years, that may be one of those things, right? A lot of cons and meetings and whatever that we're all interested in seeing, kind of as uninvited guests. It's they're all pushed online now, and so we all get to. And that's actually been really interesting. I wonder how long that's going to persist, or if it's going to be a forever change in the status quo.
Yeah, because you figure there's people who would never be able to participate otherwise. They're on the other side of the planet. They can't get there logistically, economically. They're just, it's something that's completely cut off to them. So it is, once we have that, right, it's nobody really wants to go back to cutting those people off.
Why would you go back?
Yeah, right. And in fact, some of the speakers this year were virtual too. So they were kind of, beamed in via the magic of the internet. So it goes both ways.
This is a journey into sound.
What's that sound?
What's that sound?
Last week's sound was, I thought it was a little bit harder, and Dan Maloney was like, oh, that's a... And I was like, yeah, exactly. Ended up having to bleep out everything he said for the next 3 minutes afterwards because it was all spoilers. So you hit somebody in their subject area and bam, they know their stuff. Do you want to take a listen and see what happens?
Only because I know that Dan worked in dispatch and that kind of thing. Is it some kind of a teletype kind of deal?
Oh, pretty close. He said he was an old phone geek. And the first thing he said is that a Stroger switch? And I'm like, a what? But it's one of those old switches that was used in analog telephone exchanges, and they're just phenomenal. I got this one from a Lookmano computer video, actually. This is part of his Museum of Useless Technology, or whatever he's calling it. It was new to me.
And of course, Dan picks it up immediately.
But Dan was like, that's what you get for asking an old phone geek. And I'm like, yeah.
I got the model number right here.
Yeah, he pretty much did. He's like, it's either a Stroger switch or something else. And he's like, but I think it's a Stroger. And I'm like, yeah, okay. Touche.
That speaks, I guess, to the collected experience of all the contributors, right?
For sure.
We all bring these little corners of the world of technology with us. That's really cool.
There's something that will not stump somebody. That's for sure. Right.
Exactly.
And it didn't really stump our listeners either. We got 40 responses, of which 26 were correct. So good on you all out there. And they also range from the, reasonably specific, like a mechanical telephone switch, where you can hear a few numbers, and then dialed through the Stroger switch banks. And I'm like, oh, touche, another one. So really half of them are super duper specific and dead right on. Let me see, what was I going to do for random numbers? Dang it. I really need to spend some time on my random number generator. I'll admit that. I have to work. I have to put in some work for you folks.
Yeah, it's not like we do it every week or anything.
Every other week, man. I even have more time, even more time than you give me credit for. We're doing random hash from my webcam again. That one's known to be random. 26 entries, and the video's taking a picture, and the number is 12. Congratulations to Age, old-fashioned telephone relay. Congratulations. We'll get in touch with you and ask you for your t-shirt size. I guess it's been weeks since I've listed out my favorite nicknames submitted, and this time we have Arduino Enigma, who touts his Arduino-based Enigma machine recreations in the nickname, as if I'm going to read that whole thing out. Go check out Arduino Enigma. Blinking Thing, Zeta Pi Exploder of LEDs, Lookmano Tiberium, who got me even on the source of the sound sample, wow. Steve++, and Sudo Bob, who is actually, I shouldn't out anybody, but this is actually Bob who wrote sudo, and he pronounced it sudo, and wrote it in the notes. So you have to now pronounce sudo, because Bob wrote the program. If you didn't win this week, tune in next week. More sound samples coming up. All right, let's start off this week with a cautionary tale. This is a video from Big Clive, the most deadly project on the internet. And Ryan, who wrote this up, says, yeah, he actually Googled it, and this probably is one of the more deadly popular hacker/electronics projects that people get into. Lichtenberg figures, those like fractally lightning-like char marks in wood that you get from running high voltage through them when they're soaked in some kind of salt solution. And that should already, alarm bells should be ringing, right? Salt solution and high voltage. You should be thinking, danger, be careful. But apparently these type projects have become popular in the social medias, and people are not necessarily taking as much precaution with high voltage as you would wish they had. And Ryan looked it up and found something like 30-something deaths due to people electrocuting themselves making Lichtenberg figures. And that is a really dumb way to die. So be careful out there with your high voltage. And that basically is the message of Big Clive's video here. I mean, he starts off by saying a lot of these online videos, people will be using car jumper cables to connect up to the wood. And if you think about it, a car jumper cable is rated for kind of 12 volts. And here you're dealing with 3,000 volts. And you wouldn't be entirely surprised to hear that 3,000 volts can jump through insulation that's only rated for 12 volts, right? But then Clive also lists out all the number of other hazards with these projects. For instance, the transformer doesn't make any noise. It doesn't have a light on it. Whether it's on or off, you don't really know. And you want to be differently careful about a high voltage power source when it's on and when it's off, right? He points out this is the same voltage as the electric chair. Chances are you won't do it again. And indeed, at this voltage level, there is kind of a 70% chance of mortality if you take a bad shock. And to make things worse, some of these videos, they have people spraying salt solutions on the wood as the char figure is burning itself into the wood to steer it around and make it more artsy. And I totally understand that. But you're making a conductive path between you and the horrible high voltage.
As we know, nothing good comes from social media. This is just a perfect example. Well, it's people, like you said, who have no idea, and they're just, oh, this looks cool, and they're spreading this information. But no, I mean, even, if there's anybody to break this down, it's Big Clive, right? I like where he talks about, even if you had sort of like this half sense about how to deal with voltage, and you say, haha, I'll keep my one hand behind my back or something, one of those basic principles, even that's not going to do you any good. Because he says at this kind of voltage is, your shoe isn't a good enough insulator anymore. If you're, in a garage on like a concrete floor or something, it'll pass right through the soles of your shoes. So you really need to know what you're doing. Or, maybe just not do this at all. Find another hobby.
Yeah, no, I really liked his kind of listing out all of the dangers. And the one you just mentioned is the big one, right? Is that when you get up high enough voltage, both wires are live. Like, it's not like you have to grab two wires and then you're going to electrocute yourself. Right. The ground path is going to go through your feet and into the ground pretty much no matter what you do. So both wires are like independently deadly, which is not true of, grabbing one of the mains wires coming out of your socket. Don't do that at home either.
Yeah, right.
But, at least there you stand a chance. Here, you're going to couple capacitively at least to ground and you're going to get zapped. I think the other thing that he points out here is that people are doing this with microwave oven transformers because they're readily accessible, and that's a bad choice because they're built to push a lot of current to heat up your food, right? And what you want instead is something with even more voltage if possible. 10K would be fine, but current limiting built in. And so he suggests using like a neon sign transformer for this because they're kind of, they all have, a lot of them have active circuitry in them or ballasts that like limit their current to kind of in the 15 to 25 milliamps range, which will make you wish you hadn't put yourself in the circuit, but most of the time won't kill you.
You'll live to have regrets.
He says if you do insist on doing this with a microwave oven transformer, there's still some precautions you can take that'll make it safer. And I thought they were pretty good. One is just a light to show you when the thing's on. You know, a danger, this is hot, which helps you get in the right mindset about the safety situation. The other is turning it on and off with a dead man switch, which is something where you have to, with both hands, press two buttons that are far enough away from each other that you can't cheat it, basically. And that as soon as you let go of, the circuit stops. If you let go of either of the two buttons, the circuit stops. And that's great because it gives you something to do with both of your hands, so you know you're not tempted to touch it while it's on.
Right.
But then he also suggests just don't get anywhere near it when it's running. You know, dead man switch is nice, but take 2 steps back so you're not going to be anywhere near this thing while it's live. And that's my procedure for dealing with main circuitry and everything. Like, I do some sketchy probing of live circuits sometimes. But I do it in the following way. I'll clip up everything to it, and then I'll take just 1 step back, and then I turn it on. Like, as long as I'm far enough away when it's on, it's not going to get me. I know that much. And this is another one of those situations. And last, he says you should instead consider doing the whole damn thing in a box. Because if you can just put a plexiglass case around this thing, you can't zap yourself with it. So just contain it. Put it in a box. And this is like also the gold standard for laser safety. You can do horrible, janky things with lasers. As long as it's in a box and you're looking at it with a web camera, you're never going to go blind. This is the same like that. It's just like put it in a box so you can't touch it. You can watch it through the plexiglass window or whatever. But as long as you can't poke it with your fingers, you're going to be all right.
Well, one of the stories I was really interested in this week is called Dumping Encrypted at Rest Firmware of a Xiaomi Smart Kettle. And this comes from Alexa, who got a Mi Smart Kettle. And, of course, everything has to be smart these days, and your tea kettle is no exception. It has some Bluetooth and a smartphone app, like, you know, obviously a kettle should have. But the one thing you think you could do, right, with a smart kettle, it would be turn it on remotely, except no. That is like the feature it doesn't have. I'm not actually sure what it does in the end if you can't turn the thing on from the smartphone, but neither here nor there. The idea was, he said, okay, well, I'll just pull the firmware off the thing and I'll try to patch it in, and I'll make my own smart kettle. The hell with them. The first hurdle in this case was that the microcontroller had a separate SPI flash chip for the code. So you'd think, okay, I'll put my little reader on there and pull it. Unfortunately, it's the kind of thing where it's decrypted transparently in real time when the chip reads from it. So the chip, without even realizing it pulls it off the flash and it decrypts it. But when it's just sitting there, it's in a format that we can't easily read. His idea was to get into the bootloader and run a little stub program kind of from memory that would read from the chip, read the contents of the flash, which he thought was going to work for him. But whether it was happenstance or something planned, it turns out if you run anything from memory through the bootloader, it erases the chip. Oh. So he was able to use the bootloader, was able to get his little program running, and then now not only did I not get anything, but now my smart kettle is just a kettle. No more smart at all. It was wiped. So now this is not uncommon, right? That we break things while we're trying to. You can't make an omelet without cracking a few eggs, right?
Yeah.
So he was like, okay, well, I broke the kettle, but at least let me keep experimenting with the hardware in here, because maybe I'll see some more gear like this down the road, which is really cool. I like that approach. Like I've broken it already, so let me see how more I can look into it further. So he goes through, he gets the documentation. And it turns out that because there's so many different kind of SPI flash chips, and the commands need to be tweaked and stuff. There's the ability to tweak the actual command that the bootloader gives the flash chip, and that includes the command that erases it when you try to read from it. So the kind of the hack here is that he was able to put some gobbledygook command in there. So when you read from the chip, instead of erasing it, it kind of skips that step, and he's able to get the contents. Now, the only thing that's not super clear to me, I read his whole thing. I don't know that maybe he bought another kettle, or maybe there's like a part 2, because he wiped the first one,
Right.
And there was no way to make a backup or anything first, so he had that's gone. Like that's just a dead end. So it's not super clear at the end if he has tested this on a second kettle, but it looks like, and it's published on GitHub if you want to risk your own device that's should say using the QN902 family of chips. He has this fix that should allow you to read the firmware without toasting the chip, and I think we're probably going to see a part 2 where he actually tries it. I'm very interested to see if it works the way he thinks it will.
Yeah, I mean, I always have troubles with physical device security like this because the one part of me is like, I really want any kind of random crazy smart devices like this in my house to be secure. And the other part of me is like, I totally want them to be hackable. And so like, I don't know if I'm happy about having the firmware all encrypted and inaccessible or not. I mean, it certainly is not meant to be no user serviceable parts inside.
Right.
I think the market for people who want to run their own firmware on their electric tea kettle is pretty small, huh?
I
guess we're a small minority.
Devil's advocate, I suppose you could say, somebody could put a firmware on there that runs the thing dry and it catches fire or something. They might be concerned about some kind of liability there. Because, this would seem to be an exceptional amount of security for a thing that boils water. Like, to encrypt the firmware in the first place seems unnecessary, but then to have this, and granted, this could be a function of the chip that they didn't even really consider, but to have this like self-destructing function that if somebody tries to, run code from memory, quickly erase the secrets on the chip. There's probably ATMs that aren't this well thought out, and this thing is just for making tea, so, but it could be, with the way things are now, that maybe this was just the chip they could get their hands on, and it ended up being way more complicated than it needed, but like, whatever, it's cheap and they had enough of them, so let's throw it out there.
This one's used in a tea kettle, but like other people using this microcontroller want to use it in projects where security does matter. So yeah, I can totally see it. All right, I give it up.
But, I always love seeing people pull their stuff apart and see how it works, especially the firmware hacking, which is, always like a tour de force, right? It's always like a multidisciplined thing. You got to figure out how to pull the stuff off and then decrypt everything. And, we haven't seen that phase yet because, again, I don't think he was ever able to get like a clean pull off of it. But I am hopeful that we'll see a part 2. At least it might be part 3 or 4 where he actually gets the firmware off there and then can pull it into something and figure out where he can patch in a new function. And then maybe they'll just hire him because he's the guy who figured out, hey, I would probably like to be able to turn the tea kettle on from my phone if you're going to make a smart tea kettle.
My next hack is blending Pepper's Ghost synthesizers and vintage TVs. This is a really cool art project by Joshua Ellingson, where he combines old televisions with Pepper's Ghost illusions, and it's a really cool visual effect. You just have to check out the video. But he's got these kind of video moving backgrounds that go along with some music he's making. And for instance, there's one where there's like a fish swimming around inside the television, and then it swims out of the television up to a beaker that's put on top of the TV, because there's a Pepper's Ghost setup in the beaker. And I think that's what spoke to Arsenius, who wrote this up. He actually wrote me an email and he's like, man, I'm sorry I wrote so much about this one. I just really love this guy's work. And in fact, you have to go check it out because he documents his synthesizers and he documents his Pepper's Ghost work. And you just have to look at it all. And he's right. Go check out Joshua's page on all of this. He's actually got a second video where he kind of walks behind the scenes of how he does his various Pepper's Ghost illusions. And if you don't know, Pepper's Ghost used to be a lot harder to pull off back in the, I don't know what, turn of the previous century. I don't know when these were fooling audiences, but basically you take a pane of glass or something transparent yet reflective at a 45-degree angle, you project up at it from below, and that reflects the image out to the audience. And so people see, a floating whatever it is you're projecting in the middle of something. And he goes through how he cuts like plastic sheets out to embed them in things like goldfish bowls and Erlenmeyer flasks and et cetera, et cetera, et cetera. It's a really fun technique. And it's made a lot easier these days because instead of having a whole movie projector underneath the stage, he just puts his Pepper's Ghost devices on top of a tablet and runs the videos that way. So couldn't be simpler to do. His combo, though, is just syncing up the video art that then transcends the boundaries of the televisions and the video into everyday household objects and then back, and then that mixing up with the music. That's really good fun and really, really cool.
Yeah, it's the synchronization is really the crazy thing. To be clear, there's a lot of videos that this guy has made. It's not like 1 or 2 or even 10. There's a lot. And I was surprised going through his YouTube channel. I mean, some of these things got like 10 views, 5 views. And they're phenomenal. Like, it's crazy. I feel like he's, we're catching him right before, the eyeballs hit him. I can't even describe. You have to watch the video. Just go watch the video. You're probably on your phone anyway. Just go and watch video.
Yeah, right.
Because, I mean, it looks so cool. And the way he has, like, the whole scene set up. And it's great. Look, it could be music videos or something. It's awesome. When it moves between the devices, I mean, it's seamless. And he's got one where there's 2 TVs on top of each other, and then I guess, like you said, a tablet with a dome on it, and the moon is like moving between these 3 things, and not even like cleanly from one to the other. Like, you'll have half is on one CRT and half is in the thing. And it's so, and I'm watching it. I'm trying to, not that I'm trying to pick his work apart, but I'm trying to see like any kind of mistake, and I just can't. It's so well done, and I had to dig into it a little bit. And he eventually says he's using like VJ software, which I guess is made for doing like a wall of displays. So okay, this is what it's made for, but using it in this context is really, really impressive. We're calling it Pepper's Ghost, but I mean, this is still functionally how like a heads-up display works, even in like a modern jet fighter or something. So it's not like this ancient, unused technology too. So if you were ever trying to say, hey, well, how do I make a little heads-up display? This is basically the same thing. And his kind of instructional videos on that replace the mason jar with something a little more practical, and you could put something like this on your car or whatever. But yeah, this is one of those ones where it even he even says in the write-up, it's very hard to describe this with words. Like, a lot of people are against watching the videos and they don't have the time for the video, but these are all very short and they're all very cool, so it's worth it.
This whole kind of combination of Pepper's Ghost idea with short flat screens reminded me of a video by our own Stephen Dufresne, rimstar.org, put out a great Pepper's Ghost on a smartphone demo video back in 2017. I'll throw the video link in the show notes. You should check that out.
I like at the end of his little tutorial video, and it's like under a minute. He's just very, very straight to the point, shows you what to do. At the end, he's like, so what are you doing? What are you waiting for? What are you waiting for? Go make one. He's like, what are you sitting here for?
Go.
Why are you just sitting here? Go make one. You got what you need. Just go do it. And I was like, wow, I felt very like, why am I not making a Pepper's Ghost? I felt suddenly
to me.
He reached through the screen and it made me inspired.
Yeah.
All right. So this next hack, it appealed to me for a couple of reasons. The idea with this one, I should say, it's plant growth accelerated tremendously with LEDs, and that title, is not is not fooling. The video from Great Scott shows what can only be called, monumental results. The idea here is there's 2 plants, right, and they're both in the windowsill, and they're both getting the same amount of sun. And in theory, for now, let's say everything else is equal. One of them is being exposed to a very carefully selected array of LEDs that are designed for plant growth, it sounds like, from this company. And I guess you could say tuned to the spectrum that this particular plant likes. Different plants have different wavelengths that they react best to. Okay. So, he runs this experiment, after I think it said 16 days, in one pot you have what's basically dirt, and the other pot it's just overflow. It's the leaves are everywhere, stuff growing crazy. It reminds me of like one of those like as seen on TV things, where like the one pot would like suddenly be black and white and it'd be like burn, and then like you go to the other one and like the music would play and there'd be like a jingle. It's like, don't you want to have like it is so crazy the difference. And immediately they're saying, oh wow, this is huge. I mean, you could use these LEDs. We're going to solve world hunger if you can, show these kind of, insane growth potential. It reminds me of me and a friend of mine years ago. We had when like Blu-ray lasers first started hitting like the second-hand market and they were cheap. We had said, I wonder if we could grow plants with lasers, and we went in and tried to find a plant that responded, because you can find this stuff. It's out there,
Sure.
It's scholarly papers like what plants respond to what wavelength. So we found some plant, and the name escapes me at the moment, but it was some plant that responds very closely to like the frequency of a Blu-ray laser. And we're like, oh, we can just like raster the laser across all the plants. And imagine if you could grow plants with this tiny little laser diode, and you could do it on a it was this this grand idea. Don't get too excited because it never went anywhere. we never actually tried it, so I don't know whether or not it would have worked, but it reminded me of that, because there is truth to finding like the special sauce that each plant likes, and finding those frequencies of light and providing it exactly what it wants. But even still, wow, wow, this no pun intended, night and day difference of just the light that's hitting it. It's hard for me to believe. And to be clear, I'm not saying this is a fake video. I'm not saying it's some kind of scam. I feel like there's gotta be something else, something that wasn't taken into account, and I don't know offhand what it is. I think Elliot has some ideas, but
I think there's a lot of stuff not taken into account here.
This is an experiment that needs to be duplicated by others, and there needs to be some rigorous scientific, investigation. Because
here's my take on this. Like, Great Scott is in northern Germany somewhere, and this was done a couple months ago. So it's done in the winter at an extremely northern latitude. There's not much sun coming in through his window. So his normal sunlight is pretty weak. And you don't want to try to grow arugula in January anyway. It's the wrong season. So it's just not going to get much action sitting there sprouting on your windowsill. The plants with the LEDs on them, on the other hand, have a reasonable amount of light. They're not starved for light, and of course they grow better. Like, I don't know if it's necessarily attributable to the wavelengths here at all, as much as just like this one plant had light and the other plant didn't, and the one without light didn't grow very much. It's also close enough to the LED thing that I bet it's also heating up the pot a little bit, which, warming plants up also helps them grow, especially if they're like Southern Italian plants. Is it a good idea to put grow lights on your plants and grow them? Hell yeah. Like, it'll make them grow faster. And I think it's a really cool experiment, and he had a good time working this out. I will say, I think this was pretty heavily sponsored by Vert Electronics. I think this was a little bit of an ad. I don't think he just got the parts for free. I bet he got, a little something on the side for this one. Now, I think the point of this was not the science of growing plants. I think the point of this was having fun making your own plant light, ordering parts, DIYing yourself up a like custom plant light. And I'm all down with that.
Yeah, and I do like the idea of, like I said, experimenting with that tuned lighting too. I think there is, some research that could be done there about like looking at whatever you want to specifically grow, and then what LEDs. And he talks a little bit in here about having like a PWM driver powered by the Arduino. You could like make a custom light cocktail for whatever you're growing, right? pretty easily by just blending the light. So I mean, there could be something, and even if it's minor gains, why not? If you could say, hey, I want oregano, I want rosemary, whatever it is, and you could just like dial it in, little knob on the back of the light that has all the herbs on it,
right?
I would like to see that, and hey, why not? Like you said, you can see with your own eyes that something's happening because the leaf looks different. It's obviously absorbing that light, so why not give it what it's asking for?
All right, my next hack is this 3D printed robot can actually pick locks. This is a great video by Lance chronicling his attempt to make a lock picking robot, actually. I don't know, I pick locks for fun sometimes, and there's kind of two factors that you want to control there. One is with one hand, usually with my left thumb, I'll be pushing up on the torque wrench, and then the other is you kind of move the pins up and down until they just click into place. And there's a little bit of a feel there. You kind of, what happens when you put a little torque on the lock is that some of the pins bind, and so you can kind of feel around with the lock pick. You find the one that is binding pressed up against the wall, and that's the one that when you shove it up just across its binding point, just across that shear pin, the lock will turn a tiny little bit and it'll get stuck in place, and then you can move on to finding the next one. That was the 10-second intro to lock picking. That actually, all of it transfers over into this robot design. He's got load cells so he can tell how much pressure he's putting on both the tensioning part and the pick part. And then he builds this really interesting 4-bar linkage parallel mechanism to make the pick move straight into the lock and then up and down, but not tilt, so he doesn't have to worry about that degree of freedom. One of the parts that I thought was really interesting along the development is that he hooks up the load cells to this thing and then kind of has to calibrate them. And of course, you can do that by hanging weights on them, but the other thing you can do to calibrate them is you put the load cells into the robot and then you kind of manually pick the lock while the robot is reading it. And he has a really neat couple minute shots of him picking the lock while the robot is reading out how much tension he puts on it and stuff. And that's actually really cool. I was kind of wondering in the back of my mind how you could do this, because I think he really has it right here. I think he really has kind of the fundamentals of the system, that is tension on one and picking pressure on the other, and his robot has probably the right feedback. I mean, it's got pressure on both of these axes, but I do wonder if you can kind of write down or put into code this kind of feel that you eventually develop if you practice lock picking a bunch. I'm going to spoiler this a little bit. At the end, he's programming the machine to do it, and he's having trouble getting the movement of the pick in and out, and he just pulls it out by his hand, and he ends up kind of unintentionally raking all the pins while he has the tension held by the tensioning part of the robot on there, and bam, the lock comes open. And so he's like, I wasted weeks of effort working on the pin pushing part of the robot, and it turns out all I have to do is go crick and pull the thing out, rake the lock, and it opens right up. And that's funny because that actually is also an experience you'll get from lock picking. There's like this kind of really nuanced, I'm feeling every pin approach. And then there's really just the buy a pick that's got some wiggles in it and go whoop and see what you can get out. And both of those approaches can work for you. One of them feels like you're cheating, but, you know, when the lock opens, you're not cheating.
Well, you know, I'm almost a little skeptical of that whole thing. Oh, I wasted my time. Because, like, if all you were concerned about was, like, your time, you would probably, like, put a pick gun on an arm, you know? Like, because there already are pick guns. You can
That's right.
They're well known. I mean, you know, or you could even, you put, like, they put a pick on, like, an electric toothbrush and just vibrate the pins. Like, if all you wanted to do was make it fast, you know, you would just put the pick in there and shake it while you, you know, put tension on it. So I think there's, you know, at least underselling the project a little bit. This was definitely, you know, an effort to recreate the nuance of doing it the right way and not just the mechanical, quickest possible way. And you know, to that end, it is amazing. Like the machine itself, whatever robot you want to call it, it is like whimsical in a way, almost like the way it looks. I'm in love with the I don't know how you describe it, like the angles that where it goes into where the actual pick is, like those really like swooped pieces that like there's no reason to do it that way other than to look cool, you know. You could have just done like 45-degree angles, but it's very like organic kind of design that you can see like the printer was kind of struggling with because like the edges are real rough, but hey, it looks cool. And I actually didn't notice until looking at it again now where that second load sensor is, I guess on the putting tension on the on the thing. I just, you see the one horizontally, but the other one's facing like away from the camera. I didn't realize that until looking at it closely. Like you said, it was interesting though, where he kind of picked it and read the information coming from the load sensors. I almost wonder if there's not a machine learning application there where it could, capture enough data and just figure out like what's the ideal tension for certain brands of locks and that kind of stuff.
No, I think that's the coolest part of this project is the idea that you could actually kind of get data on, what the requisite tensions and forces and all that are for lock picking. And I think that would be, really cool just to be able to quantify it. And I think that's cool, kind of over and above I made a lock picking robot. It's also really neat to be like, I've made a device that can kind of quantify what goes on with lock picking. And I bet if he put a bunch of different locks in there, he would find different things. I mean, let's be honest, his target was a padlock, and I think it was a cheaper 4-pin padlock.
Right.
Like, I think this isn't the highest bar he could have set himself here.
As evidenced by just pulling the pick out and opened it. It was not the highest end target.
But I do think there's value in kind of instrumenting this sort of stuff. And I'm stoked to see if he makes a second video where he picks a harder lock, or if he decides to ever push this on to try to handle more difficult locks. It could be really interesting.
All right. Well, I saved this one for last because it is not really a hack. If you could feel free to skip ahead if it's too spicy of a topic, perhaps. But this is news that John Deere used their ability to remotely disable their tractors to shut down estimated $5 million worth of farm machinery that was stolen from the Ukraine by, invading Russian forces. With everything going on, it's very easy to look at this as a win and be like, yeah, well, that's what you get, right, for looting and invading, rob you of your ill-gotten spoils. And sure, that's one way to look at it, but it's also kind of terrifying that a manufacturer has this ability, because even if they're on the right side of moral, whatever you want to call it, in this case, it's a very slippery slope. If we allow the manufacturer of anything, not whether it's a smart TV, a phone, or a big green and yellow tractor, once we allow them to be the judge, jury, and executioner of this kind of thing, who else gets on the list of having their stuff shut down? Now, okay, fine, it's Russian looters. We can all kind of get behind that from a moral standpoint. But what if it's the farmer who missed his payment, and all of a sudden he can't use his machine? You could say, oh, well, hey, sure, it's a high-end tractor. This is big money. This is not, a cheap little smart TV or something. But no, because we've already seen the same thing happen. We wrote about, I think, last year, where some Samsung smart TVs were stolen by looters, and they were able to blacklist them from the services or whatever. And so it's not like it's a technology that's only being built into expensive high-end stuff. This is a very pervasive thing right now. Everybody wants to have this ability because they want to be able to shut you off if you don't play by the rules. And, the danger is always, who makes up the rules. And when the rules change, what side of the fence are you going to be on? And it's a tough one, and the comments kind of reflect that, where you see some people will say, yeah, this is great, and then the other ones are like, well, it's great in maybe this case, but there's always the what's next, what's going to be the next step. And once this has been done and allowed and actually celebrated in some ways, it's much easier to start utilizing this technology for less clear cut purposes, put it that way.
Oh, yeah, this is totally the ends justifies the means argument, which is morally bankrupt. I think, like, I wouldn't even be surprised if John Deere's PR people were behind getting this story out to the news. They're like, see, we can do good with our evil, but we mostly do evil with our evil. Like,
because
I mean,
everybody,
it's
well, no, I was gonna say, because everybody's been doing it. There's been this big push to leave the Russians in the cold, right? And we're not going to get into all the politics behind it, but like every company has been like you're
Sure.
saying, this PR thing saying, oh, we're going to not serve, McDonald's is going to leave, or Sony is
Yep.
going to turn off, you can't buy PlayStation games in Russia. And it's very acceptable right now with everything going on. So you can get away with this. No one's going to say, oh, the poor Russians in this case. But,
Yeah.
it's a genie that does not easily go back in the bottle.
All right, my first quick hack is William Somsky's simple hardware switch for OS dual booting thanks to RP2040. I think this is just a really cute idea. He has the Raspberry Pi 2040 Pico board pretending to be USB mounted boot media on his computer, and that lets him attach a physical switch to it so that it can pretend to be one operating system's bootloader or another. I don't think it's important that it's a Raspberry Pi Pico here. I think what's interesting is the idea of having a physical switch on a device that emulates a USB drive to make it behave one of two different ways depending on the position of that switch. And that's got to enable all sorts of other really cool hacks. Next up, Eddie with his art project Kaleidoscope. Feelings turned into LED tree. This is kind of a Corona project. He got a whole bunch of RGB LEDs delivered, and instead of driving them with varying pulse width modulation and frazzy-bazzy colors, just takes a bunch of fixed resistors and solders them all in place. Because of part variation, there's like this subtle bluey, greeny hue variation across all the LEDs, and that coupled with his nice hot glue into silicone mold diffusers that he made makes it a kind of a beautiful plant-like magical art piece. Really, really sweet. And last up, Jim, I2C Tap helps assign blame for SDA conflicts. If there's one problem in I2C, it's that when a bunch of devices try to use the bus at the same time, it's whoever pulls it down strongest wins. If you have multiple I2C hardware devices hooked up and one of them is rogue, how do you know which it is from the voltage going low? The answer is in Jim's project here. You should go check it out. He's got some great tips on I2C debugging, but he's also got this device which you can make on a breadboard to help you figure out which of the many devices in your I2C chain is misbehaving.
Well, my first quick hack is wearable electronics take the 3D printing route, and this is from the 3D printing professor. And, this is a bit of a meme project, I guess. It takes a very cheap 3D printer and puts it on a forearm kind of gauntlet, complete with a little spool for the filament. We've seen 3D printers on people's backs before. We've seen the mobile 3D printer. People walking around Midwest rep with these things on them. It's always, just a funny fish out of water sight. But I think the kind of the biggest pull away from this one is just how small and cheap 3D printers have become. And this one's, I think it's under $100 US for this little cute little printer that can go on your forearm. And even if you don't want to wear it like a cyberpunk gauntlet, I think it's cool to look at how the technology has moved, and there literally is no excuse, I guess, at this point not to have your own 3D printer. Next up is Need a Snack from Across Town, send Spot, and this project uses a Spot robot from Boston Dynamics with a little bin on the back and has it do your snack retrieval, because that's, of course, why they built this machine, right? To go get you a hot dog when you're hungry. But there's actually, an incredible amount of stuff going on here. You might look at this and think it's like a remote controlled thing, but it's actually all happening on the robot itself, using the new Jetson Orin platform to do all kinds of processing without an internet connection. It's all happening on there. And even when you send it away, you tell it what your order is, and it trots off to the restaurant and it orders your food in its best, Cylon intimidating voice. It is really cool to see the state of what an individual can do. A well-funded individual, let's say, with the equipment that's available. If I ever see one of these things trotting off to the local corner store to get some food, I'm going to throw a net over it personally. But it is a cool project to watch, if not the most practical thing we've ever covered. Last up is hacking toy RC cars with the Hack RF1 from Radoslav. This is you could kind of call it a non-intrusive reverse engineering, because his daughter got a little remote controlled gadget and he didn't want to break it, but he did want to figure out how to control it. So using the hack RF, just sniffed around for the signals it was sending, and there was no opening it up and probing it with the logic analyzer. This is all just done with different radio tools, and it's just a good example of what's possible with these software-defined radios and open source software and patience. Frankly, you can analyze what's coming over the air. The interesting note here is you might say, well, why do you need to hack RF? Can't you do this with an RTL SDR? And in fact, in this case, believe it or not, there's actually two-way communication between the controller and the car, which for something that, probably only costs $20 is pretty wild. And I can't even imagine why it requires two-way communication. But the transmission was actually an important part of this project.
All right, that brings us to the can't miss articles. These are long form pieces written by our fantastic Hackaday staff. Today, I've picked Ask Hackaday, Repair Cafe or Not by Jenny List. I don't know if repair cafes are a European thing, but it's a neat idea where people who know how to fix stuff and people who need stuff fixed can kind of all get together. And so, it's a bunch of nerds who are willing to help you repair your broken cell phone or toaster or whatever, and you just come in with your broken stuff and they'll help you fix it. And this sounds like exactly the sort of thing that someone like one of us or Jenny should be doing. Jenny's point here is that she has been trained a little bit as an electrician, and if something goes wrong, she just doesn't know how liable she'll be held for the accident. Like, so if she's helped someone work on something mains connected and it catches fire later on, will they be able to sue her, and will she feel horribly bad about the whole thing? And, this kind of idea that you have responsibility for helping other people's out is kind of what's at root here. I don't agree with Jenny at all, I think. There's a Good Samaritan clause. If you have taken first aid class and somebody falls down from a heart attack, you don't have to be the best qualified doctor in the room to give them CPR. And if they don't live through your trying to administer CPR for them, you're not going to be held liable for their death. And I think there has to be something like that with repair cafes too. But even, as long as you're putting in a good faith effort to make it work, I think you can be, I think you should be held harmless. I am totally not a lawyer. But that aside, I think the chances that lots of people are coming into repair cafes with big, heavy machinery that's really going to catch fire if you do something wrong is probably really slim. And my guess is it's people who have a cell phone and they can't change the battery in it. And they need someone who's able to, hot gun the back of their cell phone apart and see what they can do with that. Or it's, if people come in with appliances, even if you come in with a TV these days, what's wrong with it is that the capacitors and the backlight circuitry have gone bad, right? And so, you pop those out and nobody's house is going to catch on fire here. These are like 12-volt parts, right? It's not a problem. So I think she's worried about it a little bit too much, because I think most of what you'd be helping people out with is kind of easier, lower voltage stuff. But at the same time, I do think it's an interesting question. And how responsible are you for things that go wrong when you're just trying to help is something that I think a lot of us I don't worry about it because I'm naive and I see the world through rose-colored glasses all the time. But it is something that you could possibly worry about, I guess.
That is the point. This is a worryingly litigious kind of society. And I don't think it's outside of the realm of possibility that, they hear about this repair thing, the average Joe, they hear about this thing, they say, oh, there's somebody there who's a trained electrician. Certainly they know what's up. The repair goes wrong and they say, oh, I can't believe I brought my thing here. Somebody's got to, there needs to be restitution here. Not realizing necessarily that this was all kind of a good faith thing. Is it likely? Probably not, but I don't think it's impossible, which is kind of
Yeah,
sad
I
to
hear
say.
you. Yeah, I hear you.
It's you would think, like you said, rose-colored glasses. You would hope that anybody who brought this thing here, and I'm sure this is not cost the people anything. You would think that, hey, you did your best, no problem. But could someone? And I guess that would be if it ever, God forbid, like went to court or something. Could this be confused for like a legitimate repair company? Could someone show up under the impression that they were licensed to be doing repairs, whereas it's really just a bunch of hackers playing around?
Yeah, I hear
like you said, I am not a lawyer either, but these are things that should be brought up and they should be talked about if it's going to become more common. I think probably the answer is you just have them sign a waiver or something when they come in and say, hey, we're volunteers, we're doing the best we can, we're not professional. This isn't some company that's providing this service. Sign here on the dotted line and we'll do what we can do. And if they don't agree to those terms, then they walk out and no one's upset. That said, my kind of feeling, I think it's the first comment on this post. So Jenny runs her whole rationale. And listen, it's her opinion. If she doesn't feel comfortable, it's fine. But she's decided to not be involved in any capacity, completely cut tie, cold turkey. And like the first comment is like, okay, but you could just do stuff that doesn't involve, mains. Like you're very knowledgeable. We just talked about, farm experience and tractors. Like there's plenty of things that Jenny List can offer that does not involve AC voltages. So I think that she could, while I get it and I understand her concern, I think there's certainly a place that she could fit, that doesn't, cause this kind of conflict necessarily.
For sure. And I really like your idea of having a disclaimer at the door. But I also like some of the things people say in the comments, like you think it's bad if you're in there doing it, but you have a little bit of training. Some of the people have no training. So you'd be doing like the world strictly a service by being there, Jenny. We used to do this at my hackerspace all the time. We had an open Wednesday where people would just bring broken stuff in and we'd all like have a good chance at fixing it. And the other thing that happened there a lot is that, we kind of honestly said up front, we stand at least as good a chance of breaking this thing irreversibly as fixing it. You know what you're getting into up front, but we'd love to, have a poke around and see if we could figure it out. At least we'll get to take something apart and maybe you'll walk away with the thing working. I do think it's a really great movement. I think it's a great idea to keep devices out of landfills that could be kept out of landfills. And I think the kinds of people you'll meet there are kind of, well, frankly, they're people like me. They're crazy nerds who like to take stuff apart and or fix it. So I think in that sense, like A, there's a social good, but B, it's a lot of nerds getting to hang out. And I think both of those are good.
Just having that sounding board where you could go there and say, hey, I'm not completely helpless, but I've never recapped a power supply. Can you walk me through it? So even that is a benefit there too. Just that you're going to gain more knowledge if there's a central location for all the broken things to go and be worked on, more so than if you're just a home tinkerer. So it occurs to me, I said, oh, well, Jenny could just do something else that doesn't involve, AC power. But then I also would think personally, like if I knew what was the right thing to do and somebody brought their thing in and one of the other people is trying to like, I don't know, they're struggling, they're fiddling around. I guess I couldn't stop myself, from being like, let me help you, and I could just imagine like Jenny sitting there and she's like, all right, I'm not gonna touch any AC, no AC, no AC. And then somebody comes in with a machine and she starts like heavy breathing, like, like I want to go over there and fix it, but I can't. I've sworn that, not use my powers for this, So I guess it's easy to say just don't do it, but in practice, when imagine exactly what needs to be done, and these people are over there just fiddling around, tripping over themselves, and like all you gotta do is walk over there and kind of tap them on the shoulder. How could you not, right?
Yep, you couldn't resist.
It is easy to say, "Oh, Jenny, you're being too much," but she knows her limits more than anybody else, right? And and thinking about it, I guess I kind of do get it. Let me just keep distant. Well, my pick this week is Big Chemistry, Synthetic Oil from Dan Maloney. As the name implies, this is another entry into his series of how they do that. How do they make these things that we take for granted? And if you've read any of the previous ones, which you absolutely should, you know that he kind of takes this simple, everyday kind of question and dives in. How are these things produced, whether it be helium or whatever? In this case, it's, he was going to change oil in his car, and he was looking at the store, and you got the synthetic oil and the, traditional stuff, and he was like, what is this synthetic motor oil? I'll tell you right off the bat, if you're looking for a clear, concise answer as to whether or not you should buy synthetic motor oil for your car, there is not one. And I guess Dan's goal was never necessarily to give you automotive advice, right? That would be more of a Lewin article. Maybe we'll have him do the second piece of this. This is really just the science of what is synthetic oil, and is it worth it from an engineering standpoint, given that it's more money. He does kind of touch on some, quote unquote folklore about this stuff, where he said, oh, don't use synthetic oils in older engines because the tolerances are too much and whatever, or that kind of thing. And he said there is sort of an element of truth, like a lot of these things, right? The earlier synthetic oils, they could break down seals. They weren't super compatible with some of the rubbers and stuff used in older engines. Then when we're talking older engines, he kind of qualifies, more than 30 years old, like not,
right,
2010 or something. These are decently old to the point that you're probably only talking about like classic show cars or something. I don't think there's a lot of daily drivers with a 30-year-old engine in them anymore. So those kind of vehicles, at least then. But now he says that those issues have been solved. The issues that were preventing them from being used in those older engines. So if you want to, you can use a modern synthetic oil. But the kind of the meat of this is how, he breaks down how it's produced and the chemistry behind it. And I'm going to be honest with you. I read this thing like 3 times, and I'm still not sure I understand what the hell he's talking about. But that's fully my own fault. It's not Dan's fault, because he does an incredible job of explaining this, and everything's this chemistry, symbols, all that kind of stuff that kind of makes my head spin. He's got it all here. It's beautiful. He's got comments. There's a person who comments, and he's like, I do this for a living. Apparently that's a living, being a lubricant instructor. And he was like, you've done a great job. He's like, you've keyed in on stuff that, the average person has no idea about. So if you're looking for the explanation of what synthetic oil is, he's the guy to give it to you. I'm not the guy to explain it, but I can still appreciate it, I think the reason that, I kind of picked it this week is that this is the sort of article that, like most of us that work for Hackaday, I read it for years beforehand. And if you had told me 10 years ago that there would be an article about motor oil on Hackaday, I wouldn't have believed it. It would seem so out of our scope. But I think it's really interesting that, and it might speak to how things have changed about the kind of coverage we do now. But this is clearly a Hackaday article, because it's not, BuzzFeed's list of best oils for your car. Like, that's a different thing. You can get that somewhere else. This is a very serious technical discussion of synthetic oil, and I'm happy to say now what I originally would never imagine to have been, kind of in our wheelhouse. I'm happy to say that we have this kind of content now, because this is something that you're not going to get anywhere else,
What I really love about this is Dan's whole big chemistry series. Like, it was sparked by him kind of figuring out that the artificial wintergreen flavor was made from petroleum, through multiple steps. And then I love how he then turns this around to this one, and he's like, well, if synthetic oil isn't made out of oil, like, if it's not oil, what's it made out of? And the answer, of course, is just like artificial wintergreen flavor. It's made out of petroleum products in the end.
It's oil all the way down.
I think it's oil all the way down.
Yeah.
But to summarize it, it's kind of like, it's not pulled off of crude oil by fractionating like regular oil is, right? You essentially boil it, and at different temperatures you pull off what comes off. It's like distilling alcohol or whatever. You pull off different parts of the crude oil as they boil off. Synthetic oils are made by taking some of the individual components that come off and blending them back together again. And so that's the sense in which it's synthetic, is it's not really one fraction you'd pull out of refining crude oil, but it's the combination and, chemical reworking of a bunch of them. And in that sense, it's synthetic, just like synthetic wintergreen flavor is synthetic, right? It's It's made up of other smaller component parts. And I think that's kind of the interesting part here. A basic chemistry reason that this stuff would be better than regular old oil is that it doesn't oxidize, it doesn't break down, and it stands a chance of lasting longer in your car's engine because of it. 2 years ago now, I woke up in a cold sweat when I realized that I hadn't changed the oil in my car in I don't even know how long. And I'm like, panic. And I went to the dealership where they had our records, and I'm like, hey, when was the last time I changed the oil on this? And they're like, it's 20,000, 30,000 kilometers ago. You're good for another 20 or 30. And I'm like used to replacing them every 5,000 kilometers, right? Like every 3,000 miles. So, man, that was a shocker. But it's true. You put oil in there that doesn't degrade, it lasts longer. Costs more, right? Costs more, but that's progress.
And even in the comments, though, people are saying like the price difference is getting very close anyway. So if you're talking a dollar extra a quart or something,
and you don't have to change your oil for 3 years instead of 4 times a year. Like, I mean,
well, right, yeah,
there's a
that's
factor
true.
of 12 there. It could be more expensive by a factor of 12, and you'd be breaking even, right? Like it's good stuff.
Yeah, it's worth it. Spend $1. I said that Dan didn't give you a clear answer, but I guess he kind of does. Where he's like, just spend $1. They did the work. Give them the buck, and it can't hurt anything. Why not?
And that wraps it up for this week's Hackaday podcast. If you enjoyed it, let us know. editor@hackaday.com. If you've got any tips that you'd like to see us cover, send an email, tips@hackaday.com. You can find links to the show notes over at hackaday.com/podcast. And until next week,
keep on hacking.
What am I missing? What else do we say?
Have you seen anything or cool or done anything cool? You usually say that.
We also just won't stress too much about it.
So I'm like, is the dryer still running? And I can just kind of tell if I can feel it vibrating under me. Like, yeah, it's running. Yeah, here. That's it. Yeah, it was the washing machine. Taking Boston.
I don't know what to say. I think we're done with this. Roll the music.
Try that over again.